Both AMD and Intel stock CPU coolers have been made by Cooler Master for a long time now. AMD's recent revival with its Wraith and Spire class stock coolers saw a return to Cooler Master for manufacturing, and as part of our recent trip to Shenzhen and Dongguan, we visited the Cooler Master factories responsible for making those AMD coolers. Today we'll be following an AMD cooler through the process of assembly, and we'll be looking at some of the machines used to manufacture the different parts of an AMD stock cooler. If you've enjoyed our factory tours, the absolute best way to make sure we can continue to afford these expensive international trips is to support us via the GN merch store. You can pick up GPU artifacting shirt designs for $20, GN's critically acclaimed mod mats, now available in both large and medium GPU teardown sizes, blue-tinted beer glasses with gold rims, and 3D laser-etched glass statues with GN's anniversary teardown logo, each containing a high-detail design with MOSFETs, fans, and VRMs hidden within. Support these tours at store.gamersnexus.net or click the link below. Our factory tours allowed us to see every type of machine used to make the AMD coolers, although note that some of the machines were busy making different parts depending on what was going on that particular day. To make a single AMD stock cooler is incredibly complex. Before even getting to the final assembly line where each part is put together, coolers have to travel through many steps prior. Surface mount technology, or SMT lines, are needed to make the PCBs for RGB LED and fan speed, where the PCB will go through pick and place machines, conveyor belts, through ovens filled with lakes of solder, and automated optical inspection. Fin stacks have to be stamped by large machinery, but they need tools built first. Fans must be built and assembled. Plastic has to be injected to make the shroud, and heat pipes have to be filled with liquid and sintered powder, then bent to size. Let's start our journey with the aluminum fin stack tooling. Before the fin stack itself can be made, a tool for the fin stack has to be created. Cooler Master has shelves upon shelves of tools, some dating back to about 2003 or 4, with some of these tools costing upwards of $1 million for a single case. Each tool is good for a product lifecycle without meaningful degradation of the material. Tools are made by skilled machine operators and technicians who use large drills to bore holes into metal slabs. Machinery is also used to cut holes out where the stamp needs to impact the sheet metal to shape it, and tooling can take up to 60 days to complete, depending on complexity of a project and how many revisions are required, with cases taking longer. This is one of the biggest costs of the entire operation. Case tooling can cost in the hundreds of thousands of dollars, up to $1 million for instance, and CPU cooler tooling isn't cheap either. As for what a tool is, if you're not quite sure, a tool or tooling, when referring to something used to manufacture a case or a cooler component, it's really just a large piece of metal with a template stamped or drilled out of it that then mounts to the bottom of the large machinery that does stamping or other work with sheet metal to shape the final product. So a tool is just a large piece of metal. They can weigh hundreds of pounds, and it's tens of thousands, if not hundreds of thousands of dollars, depending on the complexity. Tooling often goes through at least 2 iterations before final approval, although 3 is common. These are referred to as T1, T2, T3, and so forth. The first tool is typically a rougher design, with the second one fixing most of the underlying issues. Once the tools are done, they're mounted to the multiple stamping machines so that mass production can begin. Cooler Master uses largely automated stamping for this process, with a tool mounted to the bottom of the press to stamp out the shape and rid of excess material. Aluminum is fed into the machine in sheet metal form and from a flat reel, stamped by the tool, and spit out the other side as a fin stack after traveling through the stamping process multiple times. This particular machine was making GPU cooler fin stacks, as Cooler Master is the supplier of most stock GPU coolers on the market as well, but it also makes stock CPU coolers like the one for the AMD Wraith series box coolers that come with Ryzen processors. Cooler Master has many of these stamping machines across its numerous factories, with this particular area, this one shot of the factory containing at least 10 of them. And as for all of the waste that you see spewing out, all the excess metal that's not used when it's stamped from the sheet metal that goes into the machine, that's recycled. It's sold to a third-party company that can bring it off to get recycled in a different plant that Cooler Master has only a third-party relationship with, so the metal can be melted down and reused. Once the heatsink is spat out, it gets carted over to a separate assembly area that we'll look at later. PCB manufacturing is also an important part of this process, and one that's easy to forget. This process goes through an SMT line, which we showed in our Gigabyte motherboard factory video. The process is the exact same as every other SMT line, including that Gigabyte factory. The PCB is first, designed, of course, but then it's sourced from a third-party supplier. Then it gets run through a solder paste machine with a silk screen. The solder paste applies to surface mount device mounting points on the PCB. After this, the PCB goes through automatic optical inspection, or AOI, to ensure the solder paste was properly applied. It next goes through pick-and-place component placement, which uses a reel of up to 10,000 capacitors, resistors, and other small SMDs to populate the board rapidly. Some components can be in reels of even 100,000, but the average is kind of about 10,000 individual parts per reel, and those reels contain one specific model, typically. A PCB as simple as AMD's would only take a few seconds to fully populate in one of these, whereas a motherboard would take 17 to 20 seconds just for this one part of the line. The board next goes through a reflow oven and eventually is fed through a piping hot furnace where solder is melted down from a bar that dips into the lake of solder, and then the PCB is fed through the molten solder in such a way that only the exposed contacts underneath come into contact with that lake of solder. And these machines, or these furnaces, run upwards of about 250, 260 degrees Celsius, depending. If relevant, the PCB would also go through dual inline packaging and in-circuit testing, but it depends on how complex the project is and what the customer has required for its quality assurance or for its mandated checks. Some of Cooler Master's factories even dip PCBs manually into solder hot plates, as shown in some of our footage here, but it all hinges on what the design is, how advanced it is, and what the customer calls for. To learn more about SMT lines specifically, watch our Gigabyte factory tour from a couple weeks ago when we showed how a motherboard is made. Heat pipes are the next part on the roster. We already have a dedicated video on how copper heat pipes are made, but we'll recap parts of it here. Copper heat pipes have to be shrunken on one side and welded, and then filled with copper powder and baked at 1000 degrees Celsius for 8 hours. This bonds the copper powder to the inner walls of the heat pipe to create a sintered copper heat pipe. Liquid is later injected into the heat pipe in quantities amounting to a few drops per pipe, at which point the heat pipe is vacuum sealed and cut to size. After this, the heat pipe gets bent by an automated machine, which holds and bends the heat pipes, then grabs them with a robot arm to drop them into the bin. We sped through this section in this video, but if this process interests you further, we have a 10-minute long video exclusively dedicated to the creation of copper heat pipes at Cooler Master's factory. We'll link that in the description below. Heat pipes are now ready to be delivered with the heatsink to be assembled and soldered together. In the meantime, fans have to be made for the coolers. Cooler Master also supplies the fan here, as shown in our other content where we look at the AMD cooler, but we have some footage from our Deep Cool fan factory tour, and because these processes are largely the same and automated, we can look at the previous footage to see how a fan is made. Fans first have their wires soldered to the small PCB that's internal. This is done by hand and by workers at the front of the assembly line. After this soldering process, the PCB and motor are assembled into the hub, and at the facility we previously filmed, the fan blade assembly is set upon the conveyor belt and then fed into the machine, with the fan frame moved by robotic arm from one carrier to the next. A series of robotic arms can grab and insert the bearing and bushings or other parts into the fan, using hoppers that vibrate to move small components around a track and toward a laser-guided automatic arm, and then another arm grabs the blade from the opposite conveyor belt, moves it to a carrier, moves it to the fan housing. The fan housing is fed back into the center of the machine briefly, where an arm then pushes down to secure the hub and the blades to the housing. Although we're technically showing case fan manufacturing here, the same steps, for the most part, are used in all fan manufacturing. It's just that some factories are less automated than others. There are a few differences though, and those come down to assembly, particularly with the blade, which isn't the same in the AMD stock cooler. So we need to look at that too. We've finally made it to the actual AMD cooler assembly line. The assembly line is just under 80 feet long for one of them, and is actually fairly straightforward. The assembly line starts with workers loading individual pieces onto the conveyor belt. Workers on opposite sides will load the heatsink, while others load the fan, and then others still load the fan's plastic housing, the PCBs, and so forth. Next, the LED diffuser and the fan housing are loaded into a small press that briefly vibrates and generates some heat to bond the housing to the LED ring more firmly for final assembly. The next worker grabs the fan and the fan housing and secures the fan cable to the housing with an electric screwdriver, after which another worker can screw the four corners of the fan into the housing and apply the metal retention kit. The cooler now goes through an isolated room for a simple acoustic check. All they're looking for is whether there's a catastrophic failure, like whining in the bearing, and that's it. This quality check is used for all AMD coolers through the line, and again, it's not a specific decibel level or dBA test that's done separately. It's really just to make sure there's no major issue going out to the customer. The more detailed acoustic testing for dBA measurements happens in Cooler Master's semi-anechoic chamber with a noise floor of about 6 dBA, but only during the design and validation phases of the product. Once the spec is set and the variance is known, this room is no longer needed for mass production products and can instead be used for upcoming designs and new products in the pipeline. After the small testing room, the heatsink fan assemblies come back out via conveyor belts and are tested for RGB functionality and fan RPM performance. There's a usual RPM variance in most fans of about plus or minus 10% from one to the next, so workers look for variance defined by the spec and pass or fail the device. We should note that the fans have already undergone previous quality checks during initial manufacturing, so this is really just to make sure it still works after all of those assembly steps prior. Software is used to measure performance of multiple fans and pass or fail each cooler. And next, the stock thermal paste is applied to the cooler from large tubs using a template and acrylic spreader to apply a uniform layer of paste to the bottom of the cooler. Some companies like Asetek use silk screens for this, but Cooler Master just uses an acrylic and metal template that fits cleanly over the cooler cold plate, and then they spread it over the cold plate as necessary. The next station is a taping machine, where the cooler is packaged into the plastic carrier and where its companion cables are taped to the carrier. Finally, the coolers are boxed in the AMD black box and eventually palletized for shipment out of the factory and to wherever they may go next. That's it for this tour. As stated, some of these clips we've shown are from technically other products being made, but the way it works is each day, different parts of the line are making different products. So there's never a point where you've got one product going through every single step in the line. In order to keep things efficient, companies will move maybe FinStack A through the stamping machine today, and then they'll move FinStack B through it tomorrow. Meanwhile, assembly is happening already for product C. And so you never quite have everything line up, especially since we're only at each factory for one day. But the same steps apply. We got to see all the machines used in making the AMD coolers, and in fact, these are the same steps used to make just about any CPU cooler. But we did get the excellent opportunity of seeing the specific assembly line for those AMD coolers that are used in the Ryzen processors. And of course, we're sure many of you are interested in specifically that part of things. So thank you for watching. Subscribe for more. You can go to patreon.com/gamersnexus to help us out directly, or store.gamersnexus.net, where you can pick up, for example, one of our lightweight two-tone hoodies that's currently on 10% discount with code GNSHILL at checkout. We'll see you all next time.